Literal equations, equations that have more than one variable. We've seen equations like this before. For example, the area of a circle, a equals pi r squared. A is a variable, and so is r. We've seen other equations like this, y equals mx plus b. Again, it has more than one variable, so it's known as a literal equation. Literal equations can be tricky to work with at first, but really, they're no different than the equations we've already worked with. Take a look at this side-by-side comparison as we solve 2x minus 6 equals 10 and ax minus b equals c. We're going to solve both of them for x. In the regular equation, I would begin by adding 6. We'll follow the same idea in the literal equation by adding b. Now I can add these up. In the first equation, I have 2x equals 16, and in the literal equation, ax equals b plus c. Next, when I solve an equation, I divide by 2 in order to get x alone. In the literal equation, the number in front of x is a, and so I divide both sides by a. The regular equation is now x equals 8. The literal equation is x equals b plus c over a. It can be tricky, but if you think of a regular equation and use it as your guide, it can make life a lot simpler. Here's another example. This one is not in the notes, but it is for you to try. Please pause the video here and complete the exercise. We began in our first equation by subtracting 2. In the literal equation, we're going to subtract b. That gives us 7x equals 8, and ax equals c minus b. Now, in the regular equation, we would divide both sides by 7. In the literal equation, we'll divide both sides by a. That gives us our solutions to the equations x equals 8 sevenths and x equals c minus b over a. Once again, notice all the steps that we did to the first one, we also did to the second one. The literal equation is just a little harder or a little more confusing to work with because there's so many variables. In exercises 1 and 2, we have two very similar equations, except the one on the left has numbers, and the one on the right is a literal equation. We wish to solve both of these for x, and we're going to follow the same process for each. We begin by looking at the one on the left. Notice we have that 8 in the denominator. We know that we can multiply both sides by 8, and then those 8's cancel, and we no longer have a denominator to worry about. On the literal equation, we'll do the same thing. The denominator in that case is c, and so we'll multiply both sides of the equation by c so that the c's on the left-hand side cancel out. My equations are now much simpler. 3x plus 5 equals 80, and ax plus b equals cd. Now, I'll just follow the normal process for solving an equation. I subtract 5 from both sides from the regular equation, and on the literal equation, I'll subtract b from both sides. I can now do the subtraction, and I have 3x equals 75, and I have ax equals cd minus b. Finally, we'll divide by the coefficient of x in order to get x alone. And now we have x equals 25 and x equals cd minus b over a. While they certainly look different, it turns out literal equations are very similar to the things we've done in the past. In examples 3 and 4, we have the distributive property. This exercise is for you to try. Please pause the video here and complete the exercises. We began by using the distributive property in both equations. Then we subtracted in order to get our x values alone. Next, we divide by the coefficient of x, and now we have our solutions. X equals 3, and x equals s minus pr all over p. And this is where we'll end for today. This is really everything you need to know about literal equations, but I highly recommend that you take a few minutes and just review this video now that you've taken the notes. Sometimes you get a whole lot more out of it once you've done the notes if you just take a quick run through so that you can absorb any last details. This is everything you need to know about working with literal equations.